Hi, my name is Mark Palmquist. I'm a woodworker, and today we're going to talk about wood expansion and contraction and how that will affect the joinery of your table. So here is a table that I just constructed. The top is solid walnut, and the base has a horizontal skirt, as you can see. And I'm going to be bolting or screwing the base to the top. So here's the table. Now, you'll notice that the table has grain running lengthwise, and it's about 3 feet wide. And if I just screwed the skirt directly to the tabletop, this would cause all kinds of problems. In the winter, you would see cracks forming on the end of the table. And now I will try to explain how that is so. If you look at wood under a microscope, it will the cells of the wood of the tree will appear to be like hexagonal straws and bundled together in this orientation. And the length of the cell is 60 times as long as its width. So it looks exactly like this. And you'll notice that the end of the straws are hollow, and this is designed to suck water out of the ground up through the roots and up through the tree. And this happens seasonally. So once a year, in the height of summer, when the tree is growing the fastest, more water is being sucked out of the ground and is moving through the straws or the cells of the tree. And in the winter, everything shuts down and everything contracts, and the bundle of straws or the bundle of cells shrinks. So you can see this by counting the rings of a tree. The rings are actually formed by this compression, this expansion and contraction of the cells of the tree. Now, it's interesting to note that the length of the cells do not change very much at all, but the width of the diameter of the straws changes a lot. And as you go further towards the outside of the tree, those cells are the newest cells, and they expand and contract more than the cells that are in the middle of the tree. So how much expansion and contraction on a yearly basis can I expect out of this dining tabletop? The answer might be startling, but for every foot of width, the expansion of this tabletop can be as much as 3 or 4 millimeters. So you multiply that by 3 for 3 feet, and that's 12. It's about 12 millimeters of expansion and contraction. And a lot of people don't believe me when I teach them this in my class, my wood class. So I made an instrument to demonstrate this phenomenon. So here we have a humidity meter. So what is it exactly? It's basically the cutoff of a dining table. So as you can see, the grain is in this orientation. So this piece of wood is basically 3 feet long, and it doesn't have a finish on it, and it is tacked to this board on one end, and on the other end it's allowed to expand and contract. And so let's look at this. So this is how much the board has shrunk and expanded, and it does it every year. So in the middle of winter, January of 2018, it got to its shortest length right here. And in July, mid-July, it got all the way to here. And that happens every year. And so now, as you can see, it's about, because we're in December, it's past the middle of fall, so it's on its way shrinking. It's not quite all the way to January yet, so it's not as short as the line for January. But I suspect in January, if we have a very cold and dry January, that it'll shrink another couple millimeters. So one thing you'll notice when people make a deck, the widest you can make a deck board is 5 inches, because if you make a deck board wider than 5 inches and you pin the deck board with screws, 2 screws on each end to a cross beam support, the wood will just basically rip itself right out of the screws, and that happens a lot. And so in this case, you have these skirts that run this way, which is this is not going to expand and contract, but this will. So so what I have to do is I have to create a enlarged hole. So here's my wood screw, and here's my washer. And when I drill this hole, I have to note what season of the year it is. So right now, this table is sort of it's 75% of the way to completely shrunk. So that means when I drill this hole, the screw should be on the inside, towards the inside of the hole. If I put it on the outside of the hole, yeah, so in the summer, this top is going to expand, so it's going to move this way. So this screw should be towards the inside. If I do the opposite, if I put the screw on the outside, then in the summer it won't have any space to move over. Another thing to note is the only place that you actually potentially could put glue is right here in the middle, exactly middle, centered left to right. You could put glue right here. If you put glue here, it'll rip itself apart. Any glue along this will rip itself apart when this tabletop expands or contracts. So, but the only place where you won't get that problem is right here in the middle, and it's about 5 inches wide. In fact, if you look at the construction of doors and windows, the frame, you'll notice on most doors, is never wider than 5 inches. So that's kind of the universal rule, is you can have grain going this way and that way, and you can glue them together in a 5-inch square and you won't have issues. Anything beyond that and you will have problems. Now, the only way to get away from this expansion issue, having the grains at 90 degrees to each other, is plywood. So because on plywood the layers are so thin, 1 millimeter, 1.5 millimeters, each layer does not have enough strength to separate from the other layer, which is going in the opposite direction. So that's why you don't really have this issue with plywood. It has to do with the thinness of the layers, and because they're thin, they have less strength, so they can't tear each other apart. So what exactly is the strength of the force of wood when wood is combined with water? And what is the force of that expansion and contraction? Can it overcome a screw? Well, the answer lies in discovering how the Romans used to quarry marble. So the Romans were excellent engineers. They had steel, and they had a primitive form of concrete. So the way that they used to quarry marble is they developed these 3-inch diameter screws, and they had a big beam at the top, and they would spin it. 2 people would spin it around in a circle, and they would drill holes in the marble spaced every couple feet or so with create these 3-inch diameter holes in the marble in the quarry. And so how would they separate the marble? How would they make it break apart they didn't use a hammer and chisel. They actually took a 3-inch diameter wooden dowel made out of oak, and they basically hammered it into the hole, and then they poured water under the end grain of the wooden dowels, and the force of expansion of the water combined going into the end grain of the oak dowel or tree basically would crack the marble. And so you have to understand the force of wood is it's like a hydraulic ram basically. So a lot of people, I go up into antique malls all the time, and I see furniture that is constructed wrongly, or people try to repair their dining room table by like adding another screw here or there. And if the screw is going through you know, orientation where the grain is going 90 degrees to each other, and then you run a screw through it, you're guaranteed to get a crack. So every winter, when the top is trying to shrink, you'll get a crack. And it happens all the time. And I go and I look at furniture that's been repaired by somebody that doesn't know these laws. And sure enough, they just ruin their table. And so the answer is not to put another screw in something. The answer is to, if you're going to put a screw in it, you have to have a washer, and you have to have an enlarged hole so that you actually have slippage. There's actually going to be slippage. So this skirt, I'm going to finish both sides of the skirt, and there will be no glue between the top and the skirt. Actually, both will be finished so that they can slide past each other. In fact, it's even better if you wax the surface between the two. If you don't, you get loud noises in the wintertime. In the middle of the night, I've actually had clients like wake up because they heard a loud cracking sound, and that's because there was not enough wax between the skirt, and the tabletop, and so I just had to, you know, ask them to loosen the screws just slightly, and that usually fixes the problem. But yeah, it becomes like an earthquake. So an earthquake is this buildup of tension between two objects, and then it just the tension overcomes the friction, and it just makes a big pop. So so you don't want to there's no need to over tighten these screws when you connect the tabletop to the skirt. So anyway, I hope that was helpful.